Good day, guys. Today, I'm going to discuss integration by partial fraction decomposition, case 3. That is, the denominator d of x has distinct quadratic factors. So this is the rule. For every non-factorable quadratic factor of the form ax squared plus bx plus c that we can find in the denominator d of x, there corresponds a partial fraction of the form a times the derivative of ax squared plus bx plus c. So that is 2ax plus b, and then plus b all over ax squared plus bx plus c. So we're here the arbitrary constants a and b are to be determined. Okay, guys? So let's have particular examples. So let's have the first one. So let's say we're asked to evaluate the following integrals. Number 1. So given the integral of seven x cubed plus negative 3x squared plus 19x minus 18 quantity dx all over x to the fourth plus 5x squared plus 4. First, let us check if this is a proper rational function, this integrand. the degree of the numerator is 3, while the degree of the denominator is 4. So this is a proper rational function. So the denominator, x squared, x to the fourth, plus 5x squared, plus 4 is factorable into x squared plus 1, x squared plus 4. And each of these factors is a quadratic, non-factorable. So by partial fraction decomposition, we have seven x cubed minus 3x squared plus 19x minus 18 all over x squared plus 1, x squared plus 4. These are factors of the original denominator. So we have, when decomposed, will give us two partial fractions of the following forms. So the first form we have corresponding to x squared plus 1, the first quadratic factor in d of x. So we have a times its derivative, and its derivative is 2x, over that quadratic factor, which is x squared plus 1. And then, of course, in the denominator, in the numerator, you have another term. So let's say b. And it is also an arbitrary constant. Okay, guys? So again, for the numerator, we have a times the derivative of x squared plus 1, which is 2x, plus big B, all over x squared plus 1. And for the second one, we have, so for the first term, let's have c times the derivative of x squared plus 4, so that is 2x, then plus d, all over x squared plus 4. So this is how we decompose its quadratic, what? Its quadratic, corresponding to its quadratic factor, okay? So how to solve for A, B, C, and D? So to solve for A, B, C, and D, so that this right side is equal when combined into a single fraction, will give us the left side. So we multiply each side by what? We multiply by the LCD. Okay. So of all the fractions involved, so the LCD is x squared plus 1 x squared plus 4. Okay. So after multiplying, we get on the left side 7x cubed minus 3x squared plus 19x minus 18. On the right side, for the first term, we have a times 2x times, so x squared plus 1 is cancelled. So we get another factor, x squared plus 4. And then for b, we have b times x squared plus 4. Okay? And then for the next fraction, when this is multiplied by x squared plus 1, x squared plus 4, x squared plus 4 is cancelled out. So we now have c times 2x times x squared plus 1, and then plus d times x squared plus 1. So to determine a, b, c, and d, so let us apply equating coefficients of like powers. So let me copy this so that we can see this in the next slide. Okay, so from here, let's start with x cubed. For x cubed, the coefficient on the left side is 7. On the right side, we have the terms that will have x cubed. We have a times 2, then x cubed, no? So the coefficient is 2a, the numerical coefficient. So other term with x cubed as the literal coefficient, we have 2c, so plus 2c. So that's it. So this will serve as equation number 1. Next, we have for x squared. For x squared, we have on the left side, we have -3. On the right side, terms that will give us a power of x squared, we have from this second term. So the numerical coefficient is b, and then from the last term, the numerical coefficient is d. So this will serve as our equation number 2. And then for linear x, the coefficient is 19 on the left side, and on the right side, the linear term will have a numerical coefficient of, so here we have 8ax, so we have 8a, the numerical coefficient. And then from this third term, so when c2x is multiplied to 1, we get plus 2cx. So the numerical coefficient of x is 2c. Okay, so this is our equation number 3. And then for the constant term, on the left side, we have -18. On the right side, so we'll have the constant terms are 4, b, and d. So when we add them, we get 4b plus d. So this is the constant term, the sum of the constant terms on the right side. And that is supposed to be equal to 18, -18. So this is our equation number 4. So let's solve these equations simultaneously. So from equation 1 and 3, let's work with 1 and 3. So equation number 3, let's get the difference between them. and 1, no? Equation number 3 and 1. Equations number 3 and 1. So 19 minus 7, that is 12, and that is equal to 8a minus 2a, that is 6a, 2c minus 2c, that is 0. So getting a equals what? A is equal to 2. 12 divided by 6, we have 2. So from which we can now solve C from either 1 or 3. So let us have it from 1. From equation number 1, we have 7 is equal to 2 times 2, the value of A is 2, then plus 2C. So we have 7 minus 4 gives us 3, and that is equal to 2C. Therefore, C is equal to 3 halves. Okay, guys? So let's work on equation, this time equation 2 and 4. So equation 4, let's get the difference between equation 4 and equation 2. So negative 18 minus negative 3, that is negative 15. And that is equal to 4b minus b is 3b. D minus D 0. Getting b equals negative 5. What about for value of D? So we can get it from either equation 2 or equation 4. So let's get that from equation number 2. From equation number 2, we have negative 3 equals b is negative 5, so plus D. D therefore is equal to positive 2. Okay, so let's mark those values so that we can easily recognize them. So this value, another one, D equals 2, B equals negative 5, and C equals 3 halves. So this integral now, which has an integrand that is the same with this, so can now be written. We have integral of so the first integral, the numerical coefficient, the arbitrary constant is 2. So that is times 2x plus b. B is negative 5 all over x squared plus 1 dx. And then the second integral, we get integral of, for the numerator, c, that is 3 halves, times 2x, and then plus d. D is positive 2. All over x squared plus 4 dx. So this first integral can be split into 2 integrals, getting 2 times the integral of 2x dx over x squared plus 1, leading to integral of du over u. This gives us integral of du over u, leading to ln of absolute value of u. Then the other integral we have, so negative 5 integral of dx over x squared plus 1. Then this second integral can also be split into two integrals. So the first one, we have 3 halves times the integral of 2x dx over x squared plus 4. And then the last one, plus 2 times the integral of dx over x squared plus 4. Now, in this new sum and difference of integrals, so the second integral leads to inverse tangent together with the last integral. The first and the third leading to logarithmic function. So this is integral of du over u, du over u. So we have ln of u, absolute value. But since x squared plus 1 is never negative, so we can drop the absolute value symbol. So again, we have 2 ln of x squared plus 1. And this is leading to inverse tangent with a equals 1 and then u equals x. And the differential of that x is dx. So hence we have 1 over 1 times inverse tangent of u, which is x over 1. So, and that is still x. No? Last 3 halves times, again, this is integral of d over u. We have ln of x squared plus 4. Again, absolute value is not needed anymore because x squared plus 4 is always positive. Plus, for this last integral, 2 times our a squared is 4, giving a equals 2. U squared is x squared, so x is our u, so du is dx. So hence we have 1 over a. So this takes the form of integral du over u squared plus a squared. So again, 1 over a inverse tangent of u over a. So then plus constant. Let's have it C1 because we use C in the as an arbitrary constant in our partial fraction decomposition. So let's use other arbitrary constants. So instead of C, so let us have C1 or any arbitrary constant you want as a name. Okay, so that's it. So, but I think this we can still simplify this one. So finally, we have 2 times ln of x squared plus 1. So let's put next to each other the logarithms. So plus 3 halves ln of x squared plus 4. Then minus 5 arctangent of x. Then plus arctangent of x over 2 plus a certain constant, plus a constant of integration, let's say c sub 1. Okay, so that's it. Okay, so let's have number 2. We have integral of eight x cubed minus 17x squared plus 22x minus 25 all over x squared plus 1 x squared minus 2x plus 5. Okay, guys? So then dx. Okay, so let's now check the denominator. The degree is 4, numerator degree is 3. So this is a proper rational function. We can proceed by partial fraction decomposition. So the denominator, the factors are x squared plus 1, x squared minus 2x plus 1 plus 5. This second factor is not factorable. Checking. How will we know that it is not factorable? So by discriminant. So by discriminant, we have b squared minus 4ac. So it must be less than 0. So getting 4 minus 4 times 1 times 5. And this is less than 0. Hence, this is not really factorable into linear factors with real coefficients. And of course, x squared plus 1 is not also factorable with into linear factors with linear coefficients, with real coefficients, I mean. So let's now proceed. Let's copy this. So by partial fraction decomposition, so this can be split into, we have, for the first factor, x squared plus 1 in the denominator, the corresponding numerator is a, so we have two arbitrary constant times the derivative, 2x, then plus b, all over x squared plus 1. Actually, you can have simply ax, but for convenience, so that later you will have immediate d over u, so we take the derivative of this quadratic. So instead of just having ax, to have a times the derivative. And then for the second one, we have the denominator is x squared minus 2x. So corresponding in the numerator, we have arbitrary constant c times supposed to be x, but again, for convenience, we get the derivative of x squared minus 2x plus 5, so that later when we integrate, this is immediately du with the dx over u. And then the constant d. So let's say d all over x squared minus 2x plus 5. So that's how we decompose. So we have for quadratic again, we have c times a linear function, which is the derivative of the denominator plus a constant d. So that's no, the form for what? For the decomposition or corresponding partial fraction for each denominator. So to solve for a, b, c, and d, let's multiply so each side of this equation by x squared plus 1 to get rid of the denominators so that the left side is a polynomial and also the right side is a polynomial. So getting 8x cubed minus 17x squared plus 22x minus 25, and that is equal to a times 2x times, so this is cancelled with this, so getting another factor x squared minus 2x plus 5. And then for b, x squared plus 1 is cancelled. So we get b times x squared plus negative 2x plus 5. For the second fraction, we get c times 2x minus 2, and that is multiplied to x squared plus 1. Then plus d times x squared plus 1, because this is cancelled. Okay? So let us now equate coefficients of like powers. So equating coefficients of like powers, we assume that the left side is identical to the right side. So in order to get the values of A, B, C, and D so that the left will be identical to the right side, we equate coefficients of like powers. Like powers. So let's start with x cubed, the highest power on the left and right. So 8 is the coefficient of x cubed. Those terms with literal coefficient x squared, x cubed, we have here, when multiplied here, I'll get 2a for the coefficient of x cubed. So no more here. So 1 here. So that is times 2c. So we have 2c for the coefficient of x cubed. And then this will serve as equation number 1. But we can simplify this. No? This is also equivalent to this equation. We have 4 is equal to a plus c. Okay, so let's have this equation number 1. What about x squared? So x squared, the numerical coefficient is 17 on the right side. What is the numerical coefficient of x squared? So those terms with x squared, we have this one. We'll have negative 2 times 2. So we have negative 2a. So by inspection, will this have x squared? Yes. So the coefficient is b. What about here? Negative 2x squared. No more, no? So we get negative 2x squared. So minus 2c. Okay? And then here, plus d. So this is equation number 2. What about equation number 3 that we can have? So for x, 22, the numerical coefficient on the left side. On the right side, linear x. So we have 10ax. So the numerical coefficient is 10a. So what about here? Is there a linear term? We have negative 2bx. Numerical coefficient is 2b. And then we have positive 2cx. So the coefficient is 2c. So no more, no? So this is our equation number 3. And then the last one for constant. So the constant term is negative 25. On the right side, those terms that are constants considered. So none here in the first group. In the second group, we have 5b. None here. We have one here. Negative 2c. And then plus d. Plus d. This is our equation number 4. So let's solve this simultaneously. This for equations, starting with equation 1 and 3. Equations 1 and 3. So I think better to have difference. So this is 1 and 3, no? 1 and 3. So we can easily we can eliminate what? 2c. So instead of using 4 equals a plus c, let's use this one. So let us use this as our equation 1. So instead of the simplified one. So getting, again, 22 minus 8, that is, or 8 minus 22, that is negative 14. So, and then that is equal to 2a minus 10a, that is negative 8a, 2c minus 2c, 0, then 0 minus negative 2b is positive 2b. So this is our equation number 5, which is equivalent to, this is equivalent to, when simplified, we have negative 7 equals negative 4a plus b. Equation number 5. So let's work on 2 and 4. Equations 2 and 4. Let's put it here. So working on 2 and 4, what is a better operation? Difference again. So this is 2 and 4. So negative 17 minus negative 5. So that, I mean, negative 17 minus negative 25, that is 8. Okay? So that is 8. And then a minus 5b, I mean, sorry, a minus, where's that? So we have again a minus, do we have a here? Sorry, from here, no? From equation 2. So again, negative 17 minus negative 25 is 8. Negative 2a minus, I think I got a mistake here. Let me check. This is x squared 17, x squared here. Is what? This is, I think, 4. Let me check again. 17, negative 17, negative 4x squared a. So we have negative 4a plus b minus 2c and then plus d. Okay. So again, negative. This is negative 4a. Negative 4a minus 0, that is negative 4a. B minus 5b is negative 4b. D minus d, 0. So simplifying this, we have 2 is equal to negative a minus b after dividing by 4. So this is our equation number 6. Let's work on 5 and 6. 5 and 6, let's get the sum of equation 5 and 6. What's the sum? Negative 7 plus 2 is negative 5. Negative 4a, negative a. The sum is negative 5a. The sum of b and negative is 0. Getting a equals what? A is negative 5 over negative 5. So that is 1. So we can now solve for b. So from 6, we have 2 is equal to negative 1 minus b. So b therefore is equal to negative 3 over negative 1. This is positive 3. Let me check. Negative 2 minus negative 1, positive 3, or negative 3. Sorry. So that's negative 3. So this is negative 3. Okay, so we still have C and D. So to solve for C and D, so for C, so let's move this. So we have still much space here. Yeah. To solve for C, so we can have it from equation 1, the simplified one, this simplified one. So we have 4 is equal to A plus C. So C is equal to 3. And what about D? So we can have it from equation 4. So from equation number 4, we have negative 25 is equal to 5B. But what is B? Negative 3. And then minus 2C. C is 3. And then plus D. So what is D? Equal to, so we have negative 25 plus 15 plus 6. Again, negative 25 plus 15 plus 6, negative 4. So D is negative 4. Okay, we're done with the arbitrary constants A, B, C, and D for their values. So let's mark those values. So this is equal, sorry for this. This is equal to 1. So let's mark the value. A equals 1, C equals 3, D equals negative 4, and then B equals negative 3. Okay. So this integral, the original one, is now equal to this, no? Integral of this. Of course, we put dx in each. And we substitute the values of A, B, C, and D. So getting this integral. So we get integral of, so what is our A? 1, then B is negative 3. So 1 times what? Times 2x plus B, negative 3, save 1, all over x squared plus 1. Then dx. Okay? 2x plus B. Okay, second one, we have integral of, sa C is, what is our C? 3, and then D is negative 4. So 3, 2x minus 2, minus 4 here, all over x squared minus 2x plus 5, 1 dt dx. To be able to evaluate these integrals, so for the first integral, we have to split into integral of 2x dx over x squared plus 1 leading to logarithmic function. Then minus 3 integral of dx over x squared plus 1 leading to inverse trigonometric tangent. Then plus for the second integral, we have this, no? So we can put the 3 out. Let's put the 3 outside times the integral of 2x minus 2 dx all over, so we split this also, all over x squared minus 2x plus 5. So this is integral of du over u. And then the last one, we have minus 4 integral of. So to be able to evaluate this integral, we have to convert this to u squared plus a squared form. And this is equal to x squared minus 2x plus 1 plus 4. Okay, guys? And this is equal to x plus minus 1 quantity squared plus 4. Okay, so this is now equal to dx over four plus x minus 1 quantity squared, where our u is what? Our u here is x plus 1, I mean x minus 1. What is du here? Dx. And our a is 2. So we can now evaluate its integral. Again, integral of du over u, that is ln of, no need for absolute value because it's never negative. This expression is never negative. So 3, this is 1 over a, 1 over 1 arctangent of u, which is x over 1, so it's still x. So plus what? Plus this. So this is 3 times integral of du over u. So that is ln of x squared minus 2x plus 5. Again, no need for absolute value of this because this quadratic expression is equal to x minus 1 quantity squared plus 4, and this is never negative. Plus 3, then times 1 over a inverse tangent of, because this is du over a squared plus u squared, x minus 1, that is my u, over a. So what is my a? 2. Then plus a constant. Let's have C1. Because I use C, so in the partial fraction decomposition, so I'll be using another arbitrary constant name here. So let's say C1. So let's simplify this. So getting ln of here, x squared, we just copy this. Let's copy the next logarithmic. 3 ln of x squared minus 2x plus 5, and then minus 3 arctangent of x, and then plus 3 halves tangent inverse of x minus 1 all over 2 plus C1. Okay, so that's it. Okay, let's have another one, number 3. For number 3, we have (51) x cubed minus 23x squared plus 126x minus 136 all over 3x minus 2 quantity squared multiply to x squared plus 2x plus 10 dx. Okay? So again, let's check if this denominator is under case 3. So, but of course, before that, the degree of the numerator is 3. The degree of the denominator is 4. So that is proper. So we can apply immediately partial fraction decomposition, because if it is improper, you have to divide first before you can perform partial fraction decomposition. So by partial fraction decomposition, we have so this is equal to this fraction. The partial fractions corresponding to each factor. So the denominator, this denominator is under case 2. That is linear repeated 2 times. And this one, case 3. Non-factorable quadratic. Let's see if it's really non-factorable quadratic. So b squared is 4 minus 4a, a is 1, c is 10, which is less than 0. So this is guaranteed not factorable into linear factors with real coefficients. So we now have, corresponding to this, there are 2 partial fractions. The first one, a over 3x minus 2. Because it is repeated, we have another like that. But of course, the denominator is now squared. So raised to 2. And then for the last one, case 3. So this is case 3, no? Case 3. So we have 1 partial fraction with 2 terms on the numerator. The first term consists of an arbitrary constant c times the derivative of the denominator. So 2x plus 2. So plus d all over x squared plus 2x plus 2. So again, this is supposed to be just x, but for convenience, so that this is immediately d over u. So instead of cx, I take it c times the derivative, so 2x plus 2, since after all, this is also linear. Okay? When simplified, this will be an arbitrary constant times x plus 2c plus d is just an arbitrary constant. Can be represented. So we now have, we can solve immediately for b. So let's submit here. B for b. So for b, by Heaviside rule, so we can think of a value of x that will make this 0, this denominator, that is when x is 2/3. So if x is 2/3, we evaluate now this, but we have to get rid of this, no? We have to remove this. So 51 times 2/3, quantity cubed, minus 23 times 2/3, quantity squared, plus 126 times 2/3, minus 136, all over this, no? This is removed. 2/3 times 2/3, so 2/3 quantity squared plus 2 times 2/3 and then plus 10. Okay, so let's compute for the value. 51 times 4 divided by 9 times 2 divided by 3 minus 23 times 4 divided by 9 plus 126 times 2 divided by 3 minus 136. Okay, so we get, let me repeat again. 51 times 4 divided by 9 times 2 divided by 3 minus 23 times 4 divided by 9 plus 126 times 2 divided by 3 minus 136. So the numerator is negative what? So B is negative 24 over 9. What about the denominator? 2/3 quantity squared. So that is 4 divided by 9 plus 4 divided by 3 plus 10. That is 106 over 9. Negative 4, 24 divided by 106. So 9 is cancelled, so this is negative 4. Okay? So we know already B. So we still have B, C, and D. I mean A, C, and D to solve. So let's have equating coefficients of like powers. So we can do that by first simplifying this equation, making the left and right side polynomial. So let's put it here. Equals. So we now have this fraction on the left side when multiplied by the LCD. Our multiplier is 3x minus 2, 1 squared, x squared plus 2x plus 10. So getting 51 x cubed minus 23 x squared plus 126x minus 136, and that is equal to A. So multiplied here. So 3x minus 2, 1 is left together with x squared. So 1 of 3x minus is left plus 2x plus 10. And then plus B, we have just the quadratic x squared plus 2x plus 10 multiplied to it plus C, 2x plus 2 times, cancel. I still have 3x minus 2, 1 squared, and then plus D times 3x minus 2, 1 squared. Okay. So equating coefficients of like powers. Of like powers of x. Okay, guys? So let's start with x cubed. So we now have 51 on the right side, having x cubed 3a Do we have x cubed here? What about here? When expanded 9x squared times 2x, so we'll have 18, 18c. And then no more here, no? So this is equivalent to, when divided by 3, that is 17, is equal to a plus 6c. Okay, so giving equation number 1. And then for x squared, we have negative 23, and that is equal to negative, this is negative 2x squared, positive 6, negative 6, negative 2x squared, this is positive 6x squared, then we have 4. So 4a for the coefficient. This is positive 6, negative 2, so 4a, okay? Okay, so we have here, so obviously b, the quadratic, the coefficient for quadratic. And then here, what do we have? Now, when this is expanded, I will have this one, 9x squared minus 12x plus 4. Now, what terms are with, what quadratic terms are produced out of this? When this is multiplied here, cubic, when multiplied negative 24x squared, and then another one, when this is multiplied here, 18 x squared. So this is negative 6. So negative 6c. What about here? 9d. Okay? So I think we can simplify this into, we can work on this because you know already b, no? Since you know already b, so I can simplify this into negative 23 equals 4a plus b, which is negative 4, minus 6c plus 9d. Let me now erase these things. Yeah. And this can still be simplified further into negative 23 plus 4 is negative 19. Okay? So that's negative 19 equals 4a, then minus 6c plus 9d. Plus 9d. So this is 9d. I forgot to write the d. So this is equation number 2. What about for constant? Let's have for constant. So let me write it here. For constant, the constant term is negative 136. On the right side, negative 10a. Will this have constant here? Yes, positive 10b. What about here? Positive 4 times 2, 8c. And then finally, plus, when expanded, we'll have 4, then times t, so 4b. Okay? So those are the terms having that are constant terms. So the sum is supposed to be equal to 136 negative. Yeah. So again, negative, let me check. Oh, sorry, this is 20, no? 20. Yeah, let me check. You know, checking is always important. Negative 20 And then positive 10, B plus 8C. But we know already B, no? B is negative 4. So negative 20 plus 10 times negative 4 plus 8C plus 4D. So this is negative 136. So getting negative negative 96. So negative 136 plus 40, that is negative 96, and that is equal to negative 20A. There is A here, negative 20A, and then plus 8C plus D, 4D. So this is equation number 3. Sorry, 1, 2, yeah, 3. So equation number 3. Okay, so let's now move here. So let's take these equations. Let's summarize the equations here so that we can clearly solve them. Equation 1, let's get this equation 1 together with, then let me put for the meantime here, I'll copy later. This is equation 1, equation 2. Oh, which one is equation? It is one. Control copy. I'll have it here. This one, I copy, I think I was able to erase it from this. And then equation 3, I think equation 3 can still be simplified. Equation 3, when simplified, we have divide by this negative 96. When divided by 4, we have negative 24. A equals A. What's our multiplier? 8. That I divide by 4. So this is negative 5. Sorry, this is when divided. This is what I am dividing, not this. This one. Divide by negative by 4, negative 24, negative 5A. This is the one that I am dividing. Plus 2B, divide by 4 plus D. So this is our equation number 3. Okay, guys? Let's copy all of this. And we're going to solve them simultaneously. Here. Put them in here. Okay. I can work on 2 and 3. Okay, so let's work on 2 and 3. Uh, 2 and 3. So what will I do with 2 and 3? So we multiply 2 by 9. I think we need to multiply by 9. Let me change the color. And then equation 3 is multiplied by 9. The one that is multiplied by 9. So this is plus equation 3, but equation 3 is multiplied by 9. Okay? So if I multiply equation 3 by 9 and then copy equation number 2, we have, so times, so equation 2, negative 19, that is negative 19, then add to 24, negative 24 times 9. Okay, so what's that? Again, negative, what is equation number? Again, what is I'm multiplying? This 2, no, we copy negative 19 plus this negative 24 times 9. Am I correct? Again, negative 24 plus, this is C, sorry. I think let me check that. This is 8C. So I think, again, let me check that. This is supposed to be C. It's hard to check. Okay. So let me have again plus equation 3. And equation 3 is multiplied by 9. So let's have that. Negative 19 is equal to 4A negative 6C plus 9D. And then here, negative 24. What is negative 24 when multiplied? Times 9, negative 216. I think we have to subtract, no? I think we need to, not addition. Oh, it's now messy. So this is, again, 24 times 9. But that is negative, so negative 216. This is negative 45. A times 9. This is positive 18C. And then plus 9D. So we get the difference. Negative 19 plus 216 now. That is 197. 197. When getting the difference, this is 49A. Okay. And then minus 24C. This is 0. Okay. So, and since we know already let's have substitution. From here, this is equation number 4. From equation number 4, I can replace A so 49 times A. But A is 17 minus 6C minus 24C. So getting 197 is equal to, what about 49? 49 times 17. That is 833. Would you please check, guys? So 49 times 17. Then minus 49 times 6, 294C minus 24C. So 197 minus 833 is 636. And that is equal to 294 plus 24, 318, but that is negative, no? 318C. So what is C? 636 divided by 318, negative 318. So we have negative 2. Okay. So let's mark that. This. Let's mark this value. So we have already obtained one of them. I think it's the second one. We have already B, right? We have already B here. Where's that? So this is the value of B. Negative 4. So let's have A now. I can now solve for A. So let's have here. From equation number 1, what is A? 17 equals A plus 6C. And this is equal to so this equation gives us A equals but what is A again? Sorry, let's substitute. So A we are solving, but C is what? Negative 2. So A therefore is 17 plus 12, 29. Am I right? 29? Guys? Or not? 17. Okay. So what is A? Oh, guys, what is A? So 197 as a check plus 24 times C. C is 2. And then divided by 49. So A is what? A is 5. A is 5. C is, what is my C? Let me check my C. Sorry, C is not negative. That's why they are not same obtained from here and here. This is negative. Yeah, I'm sorry for this. Negative, negative. And this is positive 2. Okay. See? It's not easy to solve, no? So we now get 17 minus 12, 5. So A is 5. As a check, 197 plus 24 times 2 divided by 49, that is also 5. Okay, this is now correct. So I can now solve for the D, the last one. D is equal to, so this is from equation number 3. From equation number 3. Negative 24 is equal to negative 5 times A is 5 plus 2 times C is 2 plus D. So D therefore is equal to negative 24 plus 25 minus 4. So that is negative 3. Hope everything is okay now. So D is negative 3. Let's now form the equivalent integral. So we now get integral of, for A, that is 5, I can put that out. And then integral of dx over 3x minus what, guys? The denominator, 3x minus 2. And then plus, B is negative 4, I think. Let's put that out. B is negative 4. So negative 4 plus negative integral of. I can bring the 3x minus 2 in the numerator, getting negative 2 as the exponent. and then plus, what about the second group, third group? C 2x plus 2 plus integral of negative, C is 2 times 2x plus 2, okay, plus d, negative 3, all over x squared plus 2x plus 10. Okay, so dx. So here, I will have here 5. I think I need to put 3 here. If this is my u, du is 3 dx. So I multiply by 3 inside. So multiply by 3. And then dx. Now, then outside we multiply by 1/3. So 3dx over 3x minus 2. Then minus 4, I think I need to put 3 also inside. Then balance outside by 1/3. Let me put here 3. I hope this will work here, the space. 3x minus 2 raised to negative 2. Oh, I need a much space. So times 3, then dx. Okay, so this is now integral of du. I mean u to the n du. Integral of u to the n du. Then this integral, I can split this into integral of 2 times integral of 2x plus 2, 1pt dx, all over x squared plus 2x plus 10. And then minus 3 integral of this part. I can put that as x is plus 1 quantity squared plus 9. So getting dx 9 here plus x plus 1 quantity squared. So everything now is okay. So this is 5 over 3 du over u. So the integral is ln of the absolute value of 3x minus 2 minus 4/3. This is u to the n plus 1 over n plus 1, then plus 2 times du over u. So this is du, this is u, ln of. Since this is equal to this quadratic is equal to this sum, which is this sum is never negative, so no need for absolute value here. And then minus 3 times 1 over 3. This is 1 over a arctangent of integral of du over a squared plus u squared. This is my u, this is du. U is squared, so my u is x plus 1, du is dx. Of u plus u, that is x plus 1 over a. So 3. So we have x plus 1 over 3, then plus a constant of integration. The constant of integration, let us have C1 or K. So simplifying further, we get 5 over 3 ln of absolute value of 3x minus 2, and then let's have, this is plus 4 over 3, and then 3x minus 2, and then plus 2 ln of x squared plus 2x plus 10 And then the last, we have arctangent of x plus 1 all over 3 here, then plus C1. Okay, that's it. Any question with that, guys? Okay, so that ends our discussion for case 3. Okay, bye guys. See you for case 4.